Hey everyone, welcome to another Arduino coding video. This time around, we're learning how to code the LED strips. Uh, we're going to be doing level 1 today, and in level 1, we're going to learn a basic script on how we're going to do a little bit of color wipe. Um, and because you're learning it from me, it's going to be a little bit more fancy than just making everything one color. This is what at the end, what it will look like, where you have the colors swapping sides. So you can see those pink and blue keep swapping sides every time. Um, so that's what we're going to learn this time. So without further ado, let's learn how to simulate this first. So if you go to Tinkercad and then you click on circuits, it'll take you to this page. We'll create a new circuit. So the point of simulating this first is just that way, in case you don't have all the materials and you can't do it, this can get us started. So what we're going to need is an Arduino. Oops. We're going to need one of these. We're going to need actually, we don't need a breadboard this time. We usually need a breadboard, but we don't need it this time. Okay, so, and the only other thing we're going to need is a strip, the LED strip. So I went to components, all components, and now I'm looking for the LED strips. Here we go. And here it says NeoPixel strip 8. It has 8 pixels in it. That's perfect. That's as many as we are going to be using here. Okay, so on this strip, we can see that there's 3 buttons. There's a D in, that means data in, so that's where we're going to send data, telling each pixel how to light up and stuff like that. There's a 5-volt pin and a ground pin. So the wiring for this is super simple. So see this arrow? It's pointing to the right. That means that's the flow of the data, so we have to put the data in here. We're going to start with any of these data pins. It has to be a PWM pin, so one with the squiggly in front of it. So you can pick any of these. I'm going to pick number 6 because why not? And I'm going to plug that into D in. Okay. Next, I need the 5-volt, which is going to come from down here. Usually we use red wires for power. Okay. And plug it in there. Okay. So I got my red 5-volt from 5-volt to power. And now I'm going to go to ground. Okay. And usually we use black for that. Okay. You could use any of the grounds. They're all the same. There's 3 different ones on an Arduino. Perfect. I mean, not really. It's a little askew. There we go. Nice. So, if we were to start this up, nothing happens. Why? Because there's no code on this. So we're going to have to code this first. So, if we want to code this and make it do the color wipe or the color swap, I suppose, what we're going to do, we're going to open up code. It's going to bring up blocks, but we don't use that because ain't nobody got time for that. All right, it's going to have some code in here already. I'm just going to go ahead and get rid of that because that's a bunch of baby stuff, and we're beyond that. Okay, so leave the void loop and the void setup. You could also, if you want, we can program this. We can do this in Arduino itself. So if you open a new Arduino window, you can do that here as well. Whatever floats your boat. I'll do it in Arduino IDE and then copy and paste it over to the Tinkercad just because I like the colors on Arduino IDE, but it doesn't matter. All right, so the first thing we need to do, so enter a comment. We're gonna put down what our goal is. Our goal is to make an LED strip, turn on and do a cool color wipe. Okay. So step one, we need to include a library. So if you're a library is basically somebody that is smarter than you and smarter than me has already done all the hard work for us and went through and figured out how to write the machine, like write code that will allow the Arduino to talk to the LED strip. That kind of code is much more complicated than the kind of code we're going to be writing. We're writing just code to tell Arduino to do something, and it'll do it. Okay, but to have those two machines, those two components communicate, that's a little bit more complicated. And somebody has already figured out how the communication system between them. So all we need to do is use that communication system to give commands, basically. So that's what all a library is. It's just somebody has gone through and made our job a little bit easier. They're giving us commands, which if you think about it, that's kind of what all programming is. Like we're using commands that somebody else has already coded underneath. So when you say pin mode, somebody has written like a giant program for that one command, pin mode, that we use in every single program. That command is, layers upon layers of other people's code that has already been done. So this is just another example of one of those layers. So to include a library, we're going to write the pound sign or the hashtag include, because we're trying to include something. And we are going to include open caret or less than sign, Adafruit underscore neopixel dot h, and then greater than sign. Adafruit is a company that produces a lot of electronics components, and so they have created these libraries for people to use. That way they can write code for their products more easily. Okay, and then we are also going to define our pins, and we're going to use a slightly more advanced technique this time. Instead of using an integer variable, let's step it up a little bit. Let's get a little more sophisticated. Let's do a hashtag define. So that should turn green for you, and we're going to call this pin. And I want pin to be number 6. I want to use the number 6 pin. Now, if you're thinking, why are we doing this instead of int pin equals 6? This is honestly identical. It's really just a stylistic choice. The only difference is if we do hashtag define, we don't have to do the pin mode set in the setup loop. So it's actually a little bit more efficient to do this. Oh, and by the way, that is step number 2. Set pins. Yeah, so we're just telling the Arduino where the thing is plugged into. So we plug this one into pin 6. Additionally, we're also going to define, so hashtag define, and I guess this should also be step 3. We're going to tell it how many pins, or sorry, how many pixels are in the strip. Okay, so how many pixels are in the strip? And so I'm going to call this num LED, as in like the number of LEDs that we have. and I'm going to call that 8 because there's 8 LEDs. And then finally, we need to actually create we need to tell the Arduino that there is a strip. Because telling it that the pin is here is not the same thing as telling it there is an LED strip. So we need to create a special kind of variable. This variable comes from this library. If you were to open this library up, for example, and I think we can, oh, no, it's not here. And now my computer's frozen. Great. Oh, there it goes. Okay, I don't want to look there because that won't tell me what I'm looking for. Well, either way, so there's a way that you can open up the actual library and read all the commands that are in the library. You could read through everything if you wanted to, but you would see in there that at one point, to create a strip, you have to create this variable to store information about the LED strip. The way you do that is by using this command, Adafruit underscore neopixel, oh, capital P. Okay, and so that turns red. That's because we're referencing this library. So we're saying, hey, look in this library. We're creating this object, this LED strip. Create, and so this LED strip is going to have some information in there. And so we need to use the Adafruit underscore neo pixel, and so that's again that's going to turn orange. This command where we tell it the number of LEDs, tell it what pin it's plugged into, and then tell it what product we are using. So we are using here the neo underscore GRB and neo underscore KHZ 800. And if you're like, bruh, where did all that come from? So the Adafruit NeoPixel stuff, that's a command in the library that literally just establishes information about the strip, the LED strips. That way the Arduino knows who it's talking to. So this command here, that is everything Adafruit programmed. They programmed all that. And so we just have to tell it, so that way the Arduino knows how many pixels there are, where it's plugged into, and what type of strip it is, so it knows how to talk to it, right? If you're like, where did those Neo GRB and Neo KHZ 800, where did that come from? It came from the packaging, actually. If you read the packaging and the data sheets, it'll tell you which one it is. So that's about it. Okay. Oh, and that's step number 4. I keep forgetting to put the steps in. Step 4. Yeah, so we're storing information about the LED strip using Adafruit commands. Okay, so now we're in the setup. This is actually super simple. Step number 5, all we have to do is start up the strip. Okay, how do we do that? Well, we're going to say, hey, remember that thing we created called the strip? Yeah, go ahead and begin that. And we're ready to roll. Cool. So that's good. That's all we need there. So the setup is ready. Let's go into the void loop. Give ourselves a little bit of space. Hit tab because we are not barbarians. Okay. Next, step 6. We need to get a little fancy here. Now we need to actually tell the LEDs what to do. So this is where the actual program is. This is where we're telling it like, hey, you want to turn this color, and then I want you to like change colors and all that sort of stuff. That goes here. So if we're trying to do a color wipe, we need to use what is called a for loop. In this type of loop, we're going to go a certain number of steps according to some variables. So in this variable, we're going to say int I is equal to 0. Why do we use I? It could be any letter, honestly. You could put that as X. It doesn't really matter. But we're saying we're going to start off at I is 0. And then we're going to say it as long as I is less than or equal to the number of LEDs plus 4. As long as it's less than that, so in this case, number of LEDs is 8 plus 4 would be 12. So as long as I is less than 12, then we're going to do the things underneath there. However, every time you do the thing under here, every time you do the thing inside of 4, I is going to add 1 to itself. And I know that might look very complicated. I promise you it's not too bad. So hit enter and it should automatically indent for you. And that's very nice. So what we need to do is we need to say, okay, that strip that we created or that we have plugged into the Arduino, we're going to set pixel color. You see that turns orange. That's because it's a command from the Adafruit library. Set pixel command. We're going to say pixel I. So the pixels are named by their numbers. So the very first one out of the gate, the closest one to the Arduino is 0, 1, 2, 3, 4, 5, and they go up sequentially. So this is saying whatever number I is on, it is going to set that color using the color command to whatever color you would like. Oh, and by the way, if you Google hex color picker, it usually, yeah. So see here where it says VRG. These are the amounts, these numbers here are what you would use for RGB. I know it says V right here, but that means blue. So if we go to like a pure blue, wait, oh, never mind, I'm sorry. Here's RBG. RBG. You can see blue is 255, because if you remember from my last video, LEDs go from 0 to 255. Well, here it is. Every color is its own RBG. So pink is mostly red, it's 255 red, and some blue in there, surprisingly. But then if we go to yellow, sure, we have a lot of red in there, but we also have a lot of green. Orange is going to be red and green again. If we go to pure red, that's 255.00. Okay, so you can play around with this. I'm going to make a teal color. Yeah, like that. So I want 0 red, 255 green, 237 blue. Okay, so I'm going to put in those numbers. So it goes R, G, and then B. red, blue, green. No, red, green, blue. I think. I always forget. I don't know. We'll figure it out. Okay, so 255 and then 237. Okay, so that's what color I want it to be. I gotta end this other parentheses because I had one open there. So we're saying set the pixel color of each thing to that color. And gotta end with a semicolon. And to make that show up, we're going to do strip dot show lol parentheses, and then let's put in a delay so that way it doesn't happen super fast. Let's put in 150 milliseconds, and let's see what that does. So copy, go back to my simulation, put that in here. Uh-oh. They don't have that library for some reason. And I don't think there's any way to add it on there. What do they have? Okay, well, let's just upload it straight to the Arduino. I'm going to call this file, what should I call it? Call it test1. You know what? That's because I'm a dingus. Yeah, that's my bad. That should have turned orange. NeoPixel. Okay, that's why it didn't work over here either. There we go. Yeah. Okay, so now we can see, oh, all the LEDs are on. What happened? Let's restart that simulation. Okay, cool. So it just turns all the lights on. That's pretty neat. But I want it to do better. I don't want to just turn the lights on and then they stay on. I want it to make colors go like this because that's cooler. So how about after I set all those things to this teal color, I have it go backwards and set it to some other color. Well, let's do that. All I would have to do is add one more line of code that's just going to go this way. So let's make that happen. So let's say strip dot set pixel color should turn orange. And instead of saying the I pin, like whatever number I is, we're going to say it's going to be the number of LEDs minus I. Let's just do minus I. That should work. And then set the strip color to, and let's pick a new color. So I did teal last time. Let's do an orange or something. Yeah, like that. Okay, so 255, 84. Okay. So we're going to do 255. Whoa. That's red, green should be 84, and then blue will be 0. And then second parentheses, that thing. And I'm just going to copy this line of code, put that into my simulation, and see what happens now. Yo, that's pretty sweet. But it's a little uneven. And this one in the middle isn't changing. So one thing that I have in my sample, and this is code that I wrote a year ago, so I don't remember. I probably figured it out just by trial and error like what I'm doing now. Let's take this I, put a parentheses around it, and say I plus 1. Okay, and I'm going to do the same thing over here. Parentheses around the I plus 1. Let's try that again, see what happens. Yeah, that's better. So now we got them changing colors. Perfect. And so if I upload this to my actual Arduino, you can see what it looks like on the finished product as well. Pretty sweet. Nice. That's level 1. Nice job, folks.